Hey everyone, and welcome back to this class, Data Science, Deep Learning in Python Part 1. In this lecture, I'm going to explain to you how to brace yourself for learning backpropagation. Let me explain why this is necessary. For a lot of people, they probably took calculus a long time ago, or worse, they've never taken calculus at all, in which case you probably need to take a few steps back before approaching this section. And so maybe your calculus skills are not as sharp as they used to be. But that's something you can take care of over time. A lot of people confuse the important aspects for the unimportant aspects of backpropagation. In particular, the important aspect, the thing that you should focus on, is actually very easy, and you've done it before. The unimportant aspect is the calculus and the derivation. Obviously, that will improve your understanding, but if you forget why we're doing what we're doing in the first place, that's worse than simply not getting it. I like to say, make sure that you can see the forest for the trees. If you're getting lost on some calculus step, and you think that because of that, you don't understand backpropagation, then you're looking at the trees. The objective of this lecture is to show you the forest. Okay, so what is the important thing that you have to keep in mind for backpropagation? Well, it's that it's actually nothing new. If you've done gradient descent with logistic regression or linear regression, the steps are exactly the same. That may be surprising, but it's true. Let me explain what these steps are. Number 1, we're going to set up a cost function. In particular, this is going to be a cost function that's appropriate for multi-class predictions, which is what we're looking at in this class. Let's call that J. Number 2, our goal is to do gradient descent on this cost function with respect to each weight of the neural network. Of course, in order to do that, we need to be able to calculate the gradient. This is going to take us down a hill, and eventually we're going to settle at some minimum. And that's really it. That's all there is to training. We just do this in a loop until the cost, J, converges. The thing that most people have trouble with is calculating the gradient itself. But keep in mind that this is just pure calculus. All it is purely mechanical calculation. Follow the rules of calculus, and you end up with some complicated result. So remember, this is not magic, and it's not even an algorithm per se. It's just calculus. We're just trying to find the derivative of something. That's like saying, here's a function x squared, let's take the derivative with respect to x. It's no different from that, except that instead of x squared, we have a much more complicated function. Now, what a lot of other resources do is instead of deriving backpropagation, they simply tell you the answer. They say, this is the equation for the error, then you multiply the error by this term, then you add up these terms, and so on. In my opinion, this is very bad, because when it's presented this way, it appears that backpropagation is some magical algorithm that was invented out of thin air. A lot of beginners are easily impressed by this, but I warn you that this is not the right way to think about this problem. If I wanted to tell you the answer, I would just say, here you go, this is the answer. It's just these equations that you see right here. There's no sense in building up the answer if you don't know where it came from in the first place. When you do that, it just seems like a series of arbitrary steps. I discussed this more in the lecture called The Wrong Way to Learn Backpropagation, in case you want to check that out. Now, let's say you're getting lost in the derivation of the gradient, either because your calculus skills are lacking or simply non-existent. Does that mean you can't proceed? Well, no. In fact, I can tell you the answer right now. You can see the gradient for W, and you can see the gradient for V right on this page. Now, what can you do with this? Well, as always, once we have the equation, the next step is to put that equation into code. As you can see, these gradients involve only two operations. Number 1, multiplication. Number 2, addition. And I'm sure that if you are taking this course, You know how to multiply and you know how to add, and you know how to do these things in Python. So is there anything stopping you from implementing gradient descent in code? I would think not. So it's important to remember what the steps are here. Number 1, we define the cost. Number 2, we take the gradient of the cost with respect to the weights, and we come up with some expression. Number 3, we take the result of number 2 and implement it in code, meaning that we do gradient descent in a loop. Now, the idea in this lecture is that even if you can't do number 2, you can still do number 3. That means maybe you don't understand how number 2 is being done, but you still understand why number 2 is being done. That's good enough temporarily. In the future, you can always come back after you've improved your calculus knowledge. That's totally fine. But don't just give up just because you got stuck on step number 2. That is not fine. Just because you don't understand the mechanics of number 2, that should not stop you from doing number 3. And so the lesson is, even if you don't understand the derivation of backpropagation, it does not mean that you can't skip to the result and do the exercise of translating the equations into code. Because the equations only require multiplication and addition, which you obviously know how to do. It's nice to be able to do the derivation, because then you'll understand where the equations for backpropagation came from, but it's not necessary in order to complete the implementation. The steps are the same as always, as they have been since we learned about linear regression and logistic regression. We set up a cost, call that j. We find the gradient of j with respect to the parameters of the model. We then do gradient descent in a loop using the gradient we found. That's the big picture. Don't forget that. Also, make sure you're not learning backpropagation the wrong way, which is doing some random steps for absolutely no reason at all, other than the instructor told you that that's the way it's done. The logic behind that approach is flawed, and I don't recommend it. So hopefully now you understand the big picture, and you remember not to get lost in all the calculus, since that's not really the focus here.